वेलकम टू ग्यास क्लासेस फॉर मैथमेटिक्स। आज हम लोग क्लास 12 थ्री डायमेंशन पार्ट नंबर 6 करेंगे। चलो देखते हैं इंपॉर्टेंट क्वेश्चन। तो ये हमारा है क्लास 12 थ्री डायमेंशन पार्ट 6 के अंदर फर्स्ट क्वेश्चन हमारा है फाइंड द डिस्टेंस बिटवीन पैरेलल लाइंस L1 L2 given by r vector equal to this and r vector equal to that. Means first equation of line L1 is given this and second equation of line L2 is given this. We have to find distance between two parallel lines. So you know equation of parallel lines is what? R vector equal to A plus alpha B vector, right? So here A1 is this and B vector is this. Again, second line, this is the A2 vector and this is the B vector. So first you write this question, okay. So our answer is what? Answer first. This is, so first you write what is your A1 vector. So A1 vector is what? That is unit vector I plus 2 unit vector j minus 4 unit vector k. This is the A1. And again A2 vector. A2 vector what? This is the second line. This is 3 unit vector I plus 3 unit vector j minus 5 unit vector k. Now what is the B vector? So this is the B vector here 2i, 3j, 6k. So both lines are parallel, so B vector will be same. So this is B vector is what? This is 2i plus 3j plus 6k, right? We have to find distance between these two parallel lines. So what is the formula of distance? D equal to magnitude of B vector cross A2 vector minus A1 vector and divided by magnitude of B vector, right? So first you put the value here. This is B vector. So B vector already given. This is 2 unit vector I plus 3j unit vector plus 6k unit vector, right? This is the B vector. Now cross. What is A2 minus A1? So this is A2, this is A1. So 3i minus 3 unit vector I minus unit vector give only 3 minus 1, 2. So this is 2 unit vector I. Again this is 3j minus 2. So 3 minus 2, 1. So this is only unit vector j. Again this is minus 5k unit vector and this is minus minus plus. So we get only minus k unit vector. So this is minus k unit vector, right? Now we have to find magnitude of B vector. So B vector is this. So we can write magnitude means coefficient of unit vector I square, coefficient of unit vector j square, coefficient of unit vector k square. So we will get 2a square plus 3a square plus 6a square. And this is what? Root under. Okay. Now, first you find this is the cross product of the two vector. So you know how can we find cross product of the two vector. So for cross product of two vectors, see here. So just you write here unit vector I, unit vector j, unit vector k. First is given 2, 3 and 6. Second 2, 1 and minus 1. So this is what? This is I. So just left this first row, first column. You will get 3 into minus 1, minus 3, minus 6. So minus 3, minus 6, minus 9. So this is what? Minus 9 unit vector I. Now this is j. So here minus j. Again left the first row and second column. So 2 into minus 1, minus 2. And this is what? Minus 12. So minus 2 minus 12, that is minus 14. So this is how much? Minus 14. Again, this is unit vector k. Now this is what? Left the first row and third column. So 2 minus 6. This is minus 4. So this is how much? Minus 4. So we can write minus 9 unit vector I plus 14 unit vector j minus 4 unit vector k. This is what? Cross product of this vector. So now we can put here. This is the rough work. So now put this value. So you will get D equal to, this is minus 9 unit vector I plus 14 unit vector j minus 4 unit vector k, right? And here this is what? 2a square, 3a square and 6a square. So this is 2 2s are 4 and 6 6 are 36. So this is 49. So 49 is what? 7. So you can find this. Again, we have to find magnitude. So this is what? Minus 9 square, 81. This is 14 square, that is 196. This is 4 square, that is 16. And this is root under. And what is this? That is 7. So we can write this 6 6 12, 12 and 1 13. 6 6 12, 12 and 1 13. Carry 1. This is 1 2, 9 to 11, 11 8, 19. And this is 1 2. So 293 upon root under 293 upon 7. So again you check, this is B vector 2i plus 3j plus 6k. And here A2 vector minus A1. So this is A2 minus A1, we get 2i plus 3 minus 2 plus j minus k. Now we get cross product of these two vectors. So here cross product we get ijk 2 3 6 and 2 1 minus 1. So j I this, so first row first column minus 3 minus 6 minus 9. Here j, so this is the first row second column negative, and then this cancel, this cancel. So minus 2 minus 12, that is minus 14. So plus 14j minus 4k. So minus 9 square 18, 81, 14 square 96, 4 square 16. When add this number 6 plus 6 12, 12 plus 1 13, and then carry 1. So 1 2, 9 to 11 and 8 19, carry 1. So this is 1 1 2 and 1 3, 1 1, this is 1 and 1 2. So this is 293, 6 6 12, 12 and 1 13, carry 1. 2 9 to 11 and 8 19, carry 1 1 2. 2 root under 293 by 7 is the distance between these two parallel lines. Okay. So for this type of question, find the distance between parallel lines. So just remember this tricky formula. D equal to B vector multiply A2 cross product of A2 vector minus A1 vector divided by magnitude of B vector. So B vector already given, and then difference of these two vector, and then go for cross and then find the answer. So now let us see the second question. Now second question, answer to. Question is what? Find vector equation of plane which is at a distance of 6 by root 29 from the origin, and its normal vector from origin is given 2i minus 3j plus 4k. Also find the Cartesian form. For this type of question, we know that's very simple formula, vector equation of plane. We have to find vector equation of plane. So vector equation of plane is what? That is r vector dot unit vector n equal to what? Distance. This is the vector equation formula, vector equation of plane. So here d is already given 6 upon root 29. Okay. So we have to find unit vector n. And here n vector is given. So first you write here n vector. N vector is what? This is 2 unit vector I minus 3 unit vector j plus 4 unit vector k. Right? This is given. So first to find the unit vector n. So that is unit vector n cap equal to what? So this is magnitude of, so this is 2i minus 3j minus 4k, right? So we have to find unit vector n vector this. So our formula is what? That is n vector divided by magnitude of n vector. So n vector is what? 2i minus 3j plus 4k and divided by magnitude of the unit vector. So what is this? This is 2a square plus minus 3a square plus this is 4a square. So we will get 2i minus 3j plus 4k divided by, this is 4 4 just 16 and this is 4, so 29. So this is root under 29. So we can write this number as a 2 upon root under 29 unit vector I minus 3 upon root under 29 unit vector j plus 4 upon root under 29 unit vector k. Now put this value in the equation first. So you will get r vector dot unit vector n, that is 2 upon root under 29 unit vector I minus 3 upon root under 29 unit vector j plus 4 upon root under 29 unit vector k equal to d. D is what? 6 upon root under 29. So this is the correct answer of the vector equation of plane which is at a distance of 6 upon root 29 from the origin. And its normal vector from origin is what? 2i minus 3j plus 4k. So this is the right answer. Now next question is also find the Cartesian form. So in Cartesian form, what will be the answer? So you know the Cartesian form is ax plus by plus cz equal to d. So in Cartesian form, our answer is Cartesian form. Cartesian form our answer is ax, that is 2 upon root under 29x plus by. So b is minus, so this is minus 3 upon root under 29y plus cz. So c is what? 4 upon root under 29z equal to 6 upon root under 29. So 29 is root 29 is common, you can cancel this. You will get 2x minus 3y plus 4z equal to 6. This is the correct answer of the equation in the Cartesian form. Okay. So when this type of question, find the vector equation of plane which is at a distance of 6 by root 29 from the origin and its normal vector from origin is given. And also we have to find Cartesian form. For this type of question, we have this formula r dot unit vector n equal to d. So here n vector is given, with the help of n vector, you find unit vector of n. So n vector is this. So unit vector equal to n vector divided by magnitude of the n vector. Okay. So our answer is this. Now put this value of unit vector in equation 1 and D already given 6 by root 29. So required equation is this. Now in the Cartesian form, our formula is what? Ax plus by plus cz equal to D. So A is 2 by root 29, B by minus 3 by root 29 and C by 4 root 29. So our correct answer. Now see the third question. So the third question is also very important. Find the direction cosine of the unit vector perpendicular to the plane this and passing through the origin. Question what? Find direction cosine of unit vector perpendicular to the plane, perpendicular to the plane r dot this and passing through the origin. So this is the given. So with the help of this equation, first you find what is the unit vector, right? That is, you have to find unit vector. So we can change this vector like this. You see, this is r vector. Okay. So now this is plus 1. So when go this here minus 1. So we are changing the sign. So this is what? Minus. This is plus. So this is minus 6 unit vector I. This is minus. So this is plus. Plus 3j unit vector. This is minus. So this is plus 2k unit vector. And this will be what? 1. Now this is r dot. This is what? R dot n vector equal to. So we have to, now we have to change this number into a what? That is the ratio. So we will go here, this what? That means we will, this is the magnitude of this is what? 6 square 36. 2 square 4. So 36 plus 4 40. 49. So root 49 is 7. So divide both sides by 7. So you will get r vector dot minus 6 by 7 unit vector I plus 3 by 7 unit vector j plus 2 by 7 unit vector k equal to what? 1 by 7. So now you find that this is the same format, r vector dot unit vector n equal to d, right? So this is the unit vector. So we have to find direction cosine. So direction cosine equal to what? That is minus direction cosine. Direction cosine will be minus 6 by 7, 3 by 7, 2 by 7. This is your right answer. So for this type of question, find direction cosine of unit vector perpendicular to the plane and passing through the origin. So first you change this number in the form of r dot unit vector n equal to d. So this is minus 6 square, 3 square, 2 square. 49 root is 7. So this is minus 6 by 7, 3 by 7 and 2 by 7, 1 by 7. So direction cosine will be coefficient of I, j, k. So this is minus 6 by 7, 3 by 7 and 2 by 7. In this way we have solved all the 3 questions of the part number 6. Thank you.